Okay, so we have a parentheses. So whenever you see a parentheses, I want you to think multiplication. So we need to multiply this parentheses by -4. So go ahead and multiply everything in that second parentheses by -4. So that gives me 2x squared plus 3x. And then you're going to take -4 times x. -4 times x is -4x. And then what's -4 times 7? -28. So now you're going to combine your like terms. So what like terms do we have in these 4 terms? Are any of these like terms? The 3x and the -4x. So we're going to add those together. So this 2x squared, and then when I add these two together, because they're like terms, what do I get? What is 3x minus 4x? -1x squared, or just -1x? So we don't change the x, the variable. We're only adding together the numbers in front. So 3 minus 4 would be a -1x. And then we have a -28. And that would be your final answer. All right, let's look at number 2. You're going to start by distributing. So this parentheses, you're going to multiply by a positive 4y. So everything in front stays the same. So we have 3xy plus 2x minus 7y squared. All right, so what is 4y times y? 4y times 1y. 4y squared. Good job. Would it be a positive or a negative 4y squared? Good job. And then we have 4y times -2x. Now that's a little tricky. So what do you think 4y times -2x would be? So first we're going to multiply our numbers. So we're going to multiply the 4 and the -2. And 4 and -2 gives you a -8. And then we're just going to write the variables. So x times y is just xy. All right, so now we're ready to look for like terms. So I'm going to start with the x, not the x, but the y squared. So these two, what do you get when you add those two together? Because they both have a y squared. So what's -7y squared plus 4y? Plus 4y squared. -3y squared. And then I'm noticing I only have this 2x. There isn't anything else that just has an x, so that's going to just be by itself. So plus 2x. And now we have two terms that have an x and a y. So -8xy and +3xy. What's -8xy plus 3xy? -5xy. Good job. And that's it. Any questions about how we did that? So today, oh, I'm sorry. Yes, Kenna. No. So the order you write it does not matter. What matters is that you have the right coefficient. So if you put the -5xy as the next term and then the plus 2x in the last, that's okay. That's a really good question. The order does not matter. All right, so now we're going to do 2 things. Well, 3 things. We're going to add polynomials, subtract polynomials, and then identify if something is a polynomial. So let's go to page 233 in our review book. So a couple of things is to find the degree of a polynomial that's going to be your greatest degree. And a monomial is when you have, well, we'll talk about that in a second. So the greatest degree is your degree of the polynomial. And what I wanted to also say is a couple of things that you're going to look for that will cause it not to be a polynomial is radicals. So you can have no radical. So a radical looks like this. Or exponents that are fractions. And you also can't have negative exponents. And then lastly, you can't have variables in the denominator. So those are the three things that we're looking for in order to determine if it is a polynomial. So these are the things that these are the three things. Okay, so let's go ahead and use that in example 1 to identify if these are polynomials. So they're not polynomials. So would this one be a polynomial? Do we see any of the no's that we said we couldn't have? Right, and one of the no's that we have is that radical. So because of that 3, the cube root of x, this is not a polynomial. It's not a polynomial. What about question B? Do we see any of those red lights? Go ahead and look at question B and see if you see any of those red lights. Nope. Okay, so in order to find the degree, so each term is a monomial. So we didn't have any red lights, so that means that each one of these terms are monomials. So to find the degree of this monomial, you're going to add together. It says the degree of the first term is 4 plus 1 or 5. So where did they get that 1? Because 1 is the exponent of b. So 4 plus 1 is 5. 2 plus 7 is 9. And this doesn't have a variable. So the degree of this last term is 0. Now, which one of these is the highest number? 5, 9, or 0? 9. So the degree of this comes from adding, comes from the second monomial. So the degree of this polynomial is 9. All right, what about the last one? Do we see, for part C, do we see any red lights? What do we have that we can't have? Negative exponents. So going back to our rules, remember we can't have any negative exponents. Yes. So the reason why this is not a polynomial is because of the negative powers. So that means that these two terms are not, and then fill in the blank, monomials. All right, so now let's give you a chance. Do the check on page 233 at the bottom. Tell me the degree of each one of those terms. So looking at these questions on the bottom of page 233, simply tell me the degree of each one. So going back again, remember the red lights are radicals, exponents that are fractions, negative exponents, or variables in the denominator. If you don't see that, then that means that it is a polynomial and you can state the degree. So let's look at this first one. Do we have any red lights? We have a fraction, but do we have an x in the denominator? What's in the denominator of this fraction? 3. So that's not an x. So this is a polynomial. So this is a yes. These are all yeses, by the way. But what would be your degree for A? 7. Now, to find your degree when there's more than one variable, you have to add the exponents in each term. So for this first term, your degree would be 9. What's the degree of this 5CD? What would be your degree? 2, because you're adding together 1 plus 1. And what's the degree of negative 9? 0. So you simply go with the highest number. And the highest number is 9. So that would be your degree. What about C? What's your degree? 10. And then D doesn't have a variable, so your degree would be 0. Yes, Deshaun.
So then what about the 6x to the 5th? Why did you exclude that?
Okay, so going back, so your degree is always the highest. It's the highest degree. You go with the highest one. So you look at each term separately, and then the degree is going to be the highest or the greatest one.
So then you use the highest exponent?
The highest exponent. And see, and the reason why, maybe you're asking me why I didn't add these together. Mm-hmm. The reason why I didn't add these together is because these aren't being multiplied. See how there's a plus sign in between them? So that's 2 separate terms. Whereas in this one, these 3 are being multiplied, so we would add them together. All right, so let's go to example 2, which is adding polynomials. So simply put, whenever you see adding, we're just combining our like terms. That's all we're going to do is combine like terms. So let's start off with our highest exponent, which in this case is x to the 3rd. So we're going to add these 2 together. So when you add those 2 together, there's 2 different ways to do it. I personally like to do it horizontally. So I'm going to focus on that method instead of the second method. So for addition, you're just combining your like terms. So when you add 6x cubed and x cubed, what do you get? What's 6x cubed plus 1x cubed?
7x.
So we're going to put a 7 right here. The next thing we're going to look for is x squareds. So we have 7x squared and negative 4x squared. So 7 plus negative 4 is what? What's 7 minus 4? 3. So we got a 3x squared. See how I'm filling in the coefficients in the bottom? Okay. And then we have a negative 2x and a negative 8x. What's negative 2x plus negative 8x? And they already have the negative in front, which is why I'm just putting a 10. And then lastly, we have a 5 and a 1. And what's a 5 and a 1? 5 and 1 together gives you what? 6. All right, now it's your turn. See if you can do it by yourself. Right underneath, you have a check. Go ahead and do that one. Add that together, get your answer. All right, anybody want to volunteer your answer? Deshaun, what did you get?
I got 6x cubed plus 2x squared plus 11x subtract 3.
Okay, did I write that right? Is that what you said?
Mm-hmm.
All right, who agrees with Deshaun's answer? All right, good. Let's talk about it. So we're going to start with the highest exponent. So we're going to collect these two. So the 2x cubed, and 4x cubed gives you a 6x cubed. The 9x squared and the negative 7x squared is positive 2x squared. 6x and 5x equals 11x. And then negative 3 did not have a like term, so it just stayed by itself, and we put that at the end. Pretty simple. All right, let's talk about subtraction. So example 3 is subtracting. So it's the same thing except for when you see a subtraction, and we had this when we did our walk around on the first day back from fall break. The first thing you want to do is distribute the negative 1. So what's happening, I'm going to explain what's happening in this example. We have a subtraction. What they did first was they distribute. So everything in the second parentheses got a sign change. So you see how this was a positive 5x to the 4th? That changed to a negative 5x. So everything in this second parentheses got a makeover. They all had a sign change. So the positive 5x to the 4th becomes negative 5x to the 4th. The positive 9x cubed becomes a negative 9x cubed. The negative 3x becomes a positive 3x. And the positive 4 becomes a negative 4. So now we're ready to combine our like terms. And we start with the highest power. So the highest power is x to the 5th. There's only one thing that has that exponent. So this does not have a like term. So we're going to start off our answer with 2x to the 5th. The next thing we're going to do is look for anything that has an x to the 4th. So we're going to go backwards. So x to the 4th would be 11x to the 4th and negative 5x to the 4th. So both of those are like terms. So what do you get when you add those two that I have underlined in blue? What would you get?
6x.
Positive or negative 6x?
Positive.
All right, so we're going to put a positive 6x to the 4th. So next we're going to look for x to the power of 3. So I only see 1. It doesn't have a friend. I don't see anything else with that exponent, so it's going to stay by itself. So 9x cubed. And then we're going to look for x squared. Do we see any x squareds? I don't see any x squared, so we're going to skip over that. What about, but we do have an x to the first. So the 7x and the 3x, we add that together, and that gives us 10x. And then at the end, we have a negative 8 and a negative 4. So what would that give you when you add those together? So the main thing to keep in mind is when you have subtraction, you have to give your second parentheses, you have to multiply that by negative 1. Then you go back in and combine your like terms. All right, do that check below it by yourself. All right, can I get a different volunteer to volunteer the answer? Kenna, what'd you get? plus 3x plus 10. Did I write that correctly? Is that what you said? Yes. All right. Who agrees with her answer? Okay, let's look at it. So because this was a subtraction sign, we're going to start by distributing a negative. So that means that this second parentheses, this becomes a negative 5x cubed, a negative 2x squared, a positive 6x, and a positive 9. Everything gets a sign change. Now we combine our like terms. So we start off with negative 5x cubed, and then we add together anything that has an exponent of 2. So that would be negative 2x squared and 8x squared. And when we add that, we do get 6. And then we look for anything that has an exponent of 1. So that would be the negative 3x and the positive 6x. When I add these two that I have in blue, that gives me a positive 3x. And then lastly, we add together our terms with a degree of 0, which are the constants. And that's a 1 plus a 9. And we get 10. So you are correct. Who remembers this from Algebra 1? So this week, what we're doing, this is all Algebra 1 stuff. All right, so homework 24, I'm going to go ahead and put that up. Use the rest of this time to work on homework 24. Now, we've only covered half of this content. So unless you remember this from Algebra 1, today you can go up to number 11. So we can only do half of them. Now, if you remember how to multiply, then you can do the whole thing. So use the rest of this time to work on homework 23. If you have questions about the retake or homework 23, let me know.